Hi everyone. So we are back to another video of Pathfinder Tuition. So for today's lesson, we're going to talk about the rate and volume of liquid. So these are the two topics that you have learned separately. In fact, usually in school, you will learn the volume of liquid first, then after which you learn about rate. But really, these two things are often put together in a PSLE question. Yeah, because when we talk about rate, as you can see from this picture, right, we can be talking about the rate at which water flow. So when we talk about rate, maybe some of you all might not have understood what is meant by rate. Rate is actually quantified as how fast, okay, for liquid, how fast the water flow. But if we talk about rate in a more general sense, it will be as per the red color box that you see at the bottom, which is actually the quantity 1 divided by quantity 2. So these two quantity, although most of the time when we talk about rate, really quantity 2, this one, refers to time. So in today's lesson, we are just going to focus on talking about the rate that got to do with time. I think even in the case of a person running, often we also relate to the time because, like for example, a person running, I can be talking about the distance traveled by the person. Okay, so that would have been quantity 1. And then if I were to divide by the time which it takes to move through the distance, then this is also a rate. And in primary 6, you learn about this. This is known as speed. Fortunate or unfortunate, in the next year to come, or rather, the next year's P6, there will be a change of syllabus where this will be taught in Sec 1. But anyway, at this point, it is still relevant, and it is also relevant in a sense that it's really just about rate. Okay, so today we're going to focus on talking about the rate of water flow, since we're going to focus on volume of liquid. Okay, and before we go to the volume of liquid, let's talk about some of the basics of the volume of liquid. So on the left-hand side, we have a rectangular tank. So under the topic Q and Q void, you learn about how water can be used to fill up the rectangular tank. Then we go through various questions where we talk about the height of the water, okay, and how much water, how long will it take to fill up the tank, and so on and so forth. So rectangular tank, what is meant by rectangular tank? It is one where the base, okay, where is the base? This part here that I have just shaded, this is known as the base, okay, the bottom part. So the base, we can have different length. So in this case, I have a length and then I have a breadth. So the breadth usually, in the case of a rectangular tank, will not be the same. Okay, and if we look across to the right side where we have a cubical tank, so when the question says cubical, it means to say that S times S times S for the volume. Right? Really everything is the same because a cube means all sides are equal. Okay, all sides are equal in the case of a cubical tank. So you need to be able to understand the difference between the two when they use different name for the container itself. And if you want to find the amount of volume of water that's in the tank, so in this case, we will take the length times the breadth times the height. And if you do so for the dimension given to you by the tank, then this is also known as the one that we are calculating now, based on the length and breadth and height of the tank, right? This will give you the capacity of the tank. Okay, and these are really words they will use in the question, so you need to be aware of them. So capacity means, okay, if you fill the entire tank, okay, what will be the amount of water that will be inside? How much water can it hold? This is called capacity. So something that's quite commonly labeled on the bottle itself. If you talk about a bottle of Coca-Cola, so maybe you buy the big one, then it's about 1.5 liter or 2 liter. Then that is a capacity. But really, when we look at a water flow or a water question like this, we don't really fill up the entire thing. So we might actually, for example, fill up only half the tank. Okay, let's say we fill up half the tank. So if you fill up half the tank, it means to say that whatever that we have talked about just now will then be half. But really, when you say half the tank, apart from the amount of water inside is half, you can also think of it this way, which is useful for you, because often in questions like this, they will talk about half the tank, 2/3 of the tank, 3/4 of the tank, so on and so forth, right? But what they really meant is that at the same time, it is also to tell you that it will be filling up half of the height of the tank. Because the cross section, which is the base, all the way up to the point at the top, right, is the same. So what happened is that, right, if you're going to talk about half the tank filled, then I will say you will actually take up half the height of the tank. Okay, so you can also think of it this way. If I ask you, if I fill the tank 3/4 full, then it will be 3/4 of the height of the tank. Right, the base will not change. Right, the base is the same all the way throughout, same throughout. Yeah, in the future you will be learning about how the change will affect, but at this point, let's imagine that it will be the same throughout. So if it's the same throughout, then you can say that half the tank will be half of the height. 3/4 of the tank will be means 3/4 of the height filled. Okay, so that's the thing. And for the case of the cubical tank, what happened is that normally in the question, right, they will just tell you the side is, let's say for example 10 cm. They won't bother telling you what is the length, breadth, and height, because by telling you the side is 10 cm, actually the length, breadth, and height will all be the same. So 10 by 10 by 10. So this is 10, this will be 10, and this will also be 10. So there's no further requirement for them to tell you, hey, actually, you know, the length is 10, then the side is also 10, and the height is also 10. No, they won't say that. They will just say cubical tank, okay, then side is 10. So that's the only thing. They might even only label one side, because you are expected to know that a cubical tank means every side is the same. Okay, so far so good. So let's move on to the next page, which I'm going to talk about something that is extremely important to you. So let's say we talk about the same thing, the volume of the rectangular tank. Okay, the volume of the rectangular tank. So there is a quick way to find what is the height. Okay, so what do I mean by that? Okay, imagine that in some question, right, they don't tell you what exactly is the length and breadth, but instead they tell you, okay, do you know that this base here is actually given by a area of maybe 10 cm square? 10 cm square, for example, right? So the base area is 10 cm square. Then they will also tell you that, oh, the volume, right? The volume is actually 100 cm cubed, right? Something like that. Then they ask you, so what is the height of the tank? Right? So they give you two information, no length, breadth, height. But what happens is that they tell you the volume, they tell you the base area. Okay. So which also means to say that, right, you need to find the height using a different manner. And this is not a cubical tank. This is a rectangular tank. So when you tell me 10 cm square, actually, what is how to find the length and the breadth? Yeah, so you'll be confused. How to find length and breadth? Okay, so no need to find. If you look at this new formula that I put here, actually not new. This is really just base area times height. And this base area here is really just length times breadth that we learned previously. Length times breadth times height give you the volume of the tank. So this base area is just length times breadth, in fact. Yeah, it's the same thing. Which also means to say that, let's say now we want to find the height. So what do we do? Alright, okay. If I take the base area times the height, gives me the volume. If I work in the opposite direction now, can I then say that actually the height is given by volume divided by base area? Okay, sorry for this thing. Okay, let me erase it. Give me 1 second. Okay, let me write again. So volume divided by base area. Yeah, it's really just that. So you want to find the volume, you take the base area times height. But you want to find the height, you take the volume divided by the base area. It's just working things in the opposite direction. And this is very useful because this also points towards one thing to you, you know. Actually, the volume of the water that you have in the tank is very much depending on how big the base area. So meaning to say that, right, if you look at these two containers now, they have different base area. Hope you can see that. This one is smaller. Yeah, the right side one is smaller. Which also means to say that if I'm going to pour this water, okay, let me draw it here. If I'm going to pour this water directly into this tank, the thing that will definitely not be the same will be the height. Okay, will be the height. So which also means to say that, right, I expect it to be higher you might actually be able to understand that without even pouring it in. But the main thing is because of this formula here, this equation, that volume is equal to base area times height, and height depends on the volume divided by the base area. So with that, we can say that if I got double the base area, I will have half the height. Okay, so double base area will equals to half the height. Okay, so if you divide by 3 to the base area, then I will have 3 times the height, so on and so forth. So this relationship is always true. And in PSLE, really a lot of questions, they need you to know this, right? This is the extra fact. While they tell you that length times breadth times height gives you the volume, but this is the extra information that can really help you to save the day. Because going to another type of question where, if let's say you want to pour water to 2 containers until you get the same height. So what do we do? Okay, so 2 containers with same height. So you have a container A, okay, you get container B, different base area. So I got some water here. Then what the question will say is that, can you pour water until both has the same height? So you might get this kind of question. A lot of people will take the volume of water I have divided by 2, but that is actually not correct. Because just now I just mentioned, if the base area are different, the volume will not be the same to get the same height. So which means to say that what you need to do is you need to find the base area 1. This is this part, right, is base area 2. Then after that, you add them together. Okay, let's say you get the total. Okay, then what you do is that you take this total base area. Okay, you take the total volume divided by this total base area to find the equal height. Okay, if next time you encounter this question, you want to try using this method, you can come back to me and tell me whether it works. It definitely will work. Okay, so if let's say you face this problem, just take the base area, add together, take the total volume, divide by that. Then you will get the same height question. Yeah, so in another video, I will be probably talking about this. So at this point, I just want to go through the basic. But this is the one of the very key important concepts that you need to know in PSLE. So I'm talking about it here. Okay, let's move on now. Let's look at the question where we talk about volume of water. So a rectangular tank is 2/3 filled with water. If all the water is poured into the cubical tank, then A asks you to determine the volume of water in the rectangular tank at first. So when this question comes about, right, a lot of times people will just take 19 times 14 times 15 to get the volume. While this is not entirely wrong as the first step, but this should not be the last step. A lot of people remember length times breadth times height will give me the volume, but not forgetting that in this question, they want to talk about the volume of water in the tank, not the capacity, not how big the rectangular tank is. So in this case, the first step will be, right, you calculate that is true, but that will give you the volume of the whole tank. Okay, it's only 2/3 filled, remember? So which means to say that, right, this thing that we calculated is, okay, there's a typo here, this is supposed to be 3, okay, 3U. Okay, this is 3 unit, because 2 out of 3. So 3U, so 1U will be 3990 divided by 3, and then after which you multiply by 2, so it's 2/3, 2 unit out of the 3 unit. So this will be the volume of the water. Alright. Then after which they say, find the height of the water in the cubical tank, round off to 3 significant figure. So applying what we just talked about just now, we can actually take the volume of water I want to pour, divided by this 15 times 15. So first thing first is that this is a cubical tank, so what we are expecting that this is also 15 cm. Okay, this is also 15 cm. So 15 times 15, this will actually be your base area. And then from there, the volume divided by the base area, we get the height from there. Yeah, okay, so this is actually what happened. And you round off the 3 significant, you can use the calculator to try, then you will get this answer. But remember, bracket order operation, we must actually find the area first, okay, before we take the volume divided by the area. You can do it in one step like this, or if you like, you can do it in 2 steps. find the area first, then after that you take the volume divided by area. Okay, so it's entirely up to you. Yeah, so this question also at the same time tell you that, hey, yeah, actually you find that it is really not the same height. In fact, I didn't calculate the height of the water initially, but if you want to, actually you can. So to find the height, right, because this is 2/3 field, the total height is 15. So if I find 2/3 of 15, you take 15 divided by 3 first, then times 2, you will in fact actually get 10 cm. So this further tell you that, yeah, actually if the container has different base area, we won't expect the height to be the same. That's what I said just now. Yeah. Okay, so once again, if you want to double the base area, then the height will also half accordingly. Okay, so that's problem number 1. Let's look at problem number 2, involving volume of liquid. So in this question, right, you are asked to find the amount of water in container A first. And once again, they say that this is a cubical tank. So which also means to say that to find the water, right, all I need to do is I take a 30 times 30A, but I did not times 30 at the end. Okay, reason is because of this, right? Some of you might have called it. It's initially half filled. Half. So I know that this is going to be 30 cm, the total height. Half filled means this will be 15 cm instead. So half of it. And from there we get actually the volume to be this 13500. Okay, so there's A. Then in B, if the bottle has a capacity of 600 ml, somehow or other you want to transfer the water into the bottle. Then you want to know how many can I fill. Usually a question like that will be the case where when you try to find it later, right, the number won't be exactly a whole number. You can actually mark my word, most of the time it is not. But maybe some rare cases, the easier question, right, they let you have a whole number. But when you really do the working correctly, you should expect not whole number, but it's for a reason. So what do we do first? We're going to put the water into different bottles. So each one of them is of a volume smaller than the volume of the water inside. And of course, at this point, you need to know that ml is actually the same as cm cubed, right? ml is cm cubed, if you remember the unit. So whatever we calculated in A is actually in cm cubed. And how do we find it? Basically, you find the total divided by the capacity of one bottle. So it's always found in this manner. You want to know how many smaller containers you're going to fill? It's the total that you have divided by the volume of one bottle. So with that, you get 22 and remainder 1 if you do the division, which also means to say what? Which also means to say that you can fill up 22 whole bottle, right? And then the last one cannot finish. Yeah, remainder 1. And then after that, you get about a maximum of 22 bottles. Okay, so remember, do not take the remainder, let it be. Okay, if you cannot finish dividing, right, take the whole number part only. Then this is the maximum number of bottles that you can fill. But this remainder 1 is really just to tell you that, oh, okay, I cannot finish filling all the bottles. Okay, this is the meaning. And in some questions, this remainder can also be used to calculate the amount of water that's left. But I won't share at this point, right? So just focus on the number of bottles I can fill. Okay, let's move on to the next part. Okay, this part is now linking back to rate. We have went through a few questions on the volume of water. Now we talk about rate. So rate of water flow into the tank, right, is a very common problem in the PSLE. So you can have either on the left side, 1 tap, or on the right side, 2 taps. Usually the 2 taps will be in such a way that one is to pour water in, one is to get rid of the water. So I can turn on both taps or I can just turn on one. Okay, so if you want to find the water that will be going into the tank, okay, the volume in the container, so you can actually take the rate of the water flow, okay, because the rate of the water flow usually will be given, for example, 3 liters per minute. This is an example of a rate. So which also means to say that in 1 minute, I can fill 3 liters of water, which is quite a lot actually, yeah. Okay, 1 minute you can fill 3 liters. This is the meaning of 3 liters per minute. Okay, and if you take this multiplied by the time, so if I take 3 liters per minute multiplied by, for example, 6 minutes, okay, so I will suggest that when you are writing this down, write the unit as well, because then you will know whether you have used the correct unit, correct quantity to find. Because if let's say this is 6 seconds or 6 minutes, right, I cannot do the sum. This is not correct. you have to change it first before you multiply them together. But now this is minute, so it's okay. So 3 liter per minute times 6 minutes, we will then get 18 liter as the answer. This is the total amount of water going into the tank in 6 minutes. Okay, so we're going to use this concept to talk about water going in and water coming out. And for the case of water going in and coming out, how to do this question, right? You can either treat them separately, but I think the faster way will be to do this. Okay, so you have tap A and tap B, right? Usually they will not be at the same rate. So if this is 3 liter per minute, okay, we use this, 3 liter per minute, then let's say this is 2 liter per minute. So instead of looking at the water flowing out as 2 and 3 separately, we can just think of it as, why not you imagine that this is not here, and then we change this to 1 liter per minute. It is the same, because 3 liter going in every minute, 2 liter coming out. So at the end of the day, the tank will only get a net or the total of 1 liter. 3 minus 2, right? You understand the logic? Yeah, so when you got 2 tap, okay, 1 in, 1 out, then I will say that you just take 3 minus 2. So imagine it's no tap B, just tap A, okay, 1 liter per minute. That will be easier for you. Okay? Okay, with that, let's come to the last few questions that we're going to go through for today's lesson. So imagine you have a figure on the left, shows a tank which is initially empty. It takes the tank to fill up a total of the entire tank, right, in 12 minutes. And the first question that will come to your mind will be, how come this tank is not only empty, but also no dimension? Empty in every sense. Yeah, but there's a reason. Let's read on. So 12 minutes, you will fill up the entire thing. And then after that, they say, if the rate is the same, never change, I want you to find the tank that you can fill in 4 minutes. Okay, so it's by proportion. Because the rate is the same, then I will say that for a same unit of time, I can fill up the same amount of water. So if 1 minute, okay, let's say for example 1 minute, I can fill 1 liter. 12 minutes, I can fill 12 liter. So 3 minutes, I can fill 3 liter. So on and so forth. This is by proportion. So which means to say that now is 4 minutes, the fraction of the tank I can fill, 12 minutes can fill the whole, right? So 1 whole is 12 minutes. Then I will say that if I only given 4 minutes, I divide by 3, right? So this will be 1 divided by 3, or 1/3. Okay, so the answer is actually 1/3. Quite easy to get the answers. No need to really scratch your head and think about how to do the calculation. So it's by proportion. If 12 minutes to fill the whole tank, then I will say that 4 minutes will be 1/3, because 12 is actually going to be 3 times of 4. Okay, 4 is 1/3 of 12. Then in this case, if you give me 1/3 the time, I fill 1/3 the tank. Okay, take note, this is only true if the rate is constant. If you anyhow apply to the non-constant rate one, and then come back to me and say you got it wrong, okay, because of this rate must be constant, cannot change. Cannot sometimes I turn on that more, then I turn on that less, then that will actually affect the time, the rate of water flow. Okay, all right. Okay, last question that I want to introduce to you is this. So in this last question, right, why I want to talk about this, because I found it extremely difficult for students at primary school to understand graph. So I find that, but reading graph is still one of the things that you need to do. Hence, I put this question here to show you how I will do it. Okay, so this is a water flowing in the tank over a period of 10 minutes. And then the graph shows you that, so at different time, what is the amount of liquid in the tank itself. Then A, what is the rate of water flowing in the tank? So you remember, you want to find the rate, you need to find the quantity one, which is the amount of water divided by the time. Okay, the only time that was given in this question is 10 minutes. So I suggest we use this. Okay, we use this. But the thing to take note is that, right, when you read the graph, do not just focus on reading the end, because you might have some water at the start, which is what happened here. So look at this part, right? Can you see that you did not start from 0? If you just look at the end, divide by the time, this is where you will get it wrong. Okay, so now we look at the start, right? You can see that I think it's about 2 liters. So at the end, it's about 38 liters. You can draw a dotted line to see it. It's roughly around 38 liters. So this is about 2 liters. You can actually see, no need to draw a dotted line. So by that, you just take 38 minus 2, which is 36 liters. After which, you take total water divided by time, which is 10. So 3.6 liter every 1 minute will be the answer. Okay, this is A. Okay, last but not least, if the tank is 4/5 filled at the end of the tank, determine the capacity. So 10 minutes can only fill 4/5 of it. All right. So which means to say that, right, in fact, the N here, which is the amount of water I have, this is 38 liter. This is in fact just 4 units, 4 out of 5. So which the last part will be a bit straightforward. It's like a fraction question all over again. So 4 units is actually 36. So imagine that 38 liter is 4 units. So what we're going to do will be 4 units will be 38 liter. Okay, so 38 divided by 4. Then this is actually what we will get. 38 divided by 4, it will be 9.5. Okay, this is actually 9.5. Then after which, we will get 5 units now. So 9.5 times 5. And then this is actually what you will get as a 47.5 liter. Okay, so this is the end of today's lesson. I hope you find today's lesson useful, especially reaching out to the people who are very weak in volume and rate questions. In the future video, I will talk more about the second rate which we will have, which will benefit the P6 student on speed. So you can actually look forward to that video. And of course, if you like today's video, please help me to like and subscribe and get more people to come on board so that this video can reach out to help more people in the future. Okay, thank you very much. I will see you again in the next video.